Okay, so we just finished up example 1. Now we're going to look at example 2, which is using a tree diagram. So a tree diagram can help demonstrate the sample space for events, which is the sample space is either like if I flip a coin, it's either going to be heads or tails, right? I have two different outcomes. The sample space is either heads or tails, okay? So looking at example 2, it says a coin is flipped twice. Make a tree diagram showing all possible outcomes. Okay, so the first thing that I can do. So if I have my first thing I'm do is either going to flip it and it's either going to be heads or it's going to be tails. Okay, those are the only two outcomes that I can have. Now, if I flip it a second time, my outcomes can either be, so this is where the tree diagram comes in. My outcome can either be, second one, either have two different choices. It can still be heads or it can be tails, okay? So maybe the first time it landed on heads, and then I flipped it again, it either lands on heads or it lands on tails, okay? Or the first time I flip it, it landed on tails, okay? So if I flip it again, it can either be heads or it can be tails, right? So this is how your tree looks when you're making your tree outcome, okay? So we're talking about the first flip was either heads or I flipped it and it was tails, okay? Then I flipped that same coin again and it either landed on heads or it either landed on tails because they're the only two outcomes that I can have. Same thing. I flipped that same coin. It landed on tails the first time. I flipped it the second time and it was either heads or tails, okay? So for each outcome, over here, we're going to say, okay, the first time it landed on heads, and the second time it was also heads. So the outcome either can be heads, heads, first time, second time, or the first time it could have been heads, and then the second time it was tails, okay? Or the first time I did it, it was tails. Second time I flipped it, it was heads, okay? So back again, the first time, maybe it was tails. And then the second time I flipped it, it was tails also, okay? So this is what your tree diagram is going to look like. So you're going to have your first flip or your first outcome or your first trial, okay? Is this one, then you're going to do your second one, what other outcomes could have happened, and then let's say this is what your outcome was, heads and heads, heads, tails, tails and heads, tails and tails, and that's what all of these are here. Okay, so if I wanted to know, it says, what is the probability of the coin landing on heads both times? So each time I either have two outcomes, right? This is going to be either heads or tails, so it's 1/2. And then the second time, there's still two outcomes and one heads, so it's going to be 1/2. And I would multiply 1/2 times 1/2 to get the P of HH equals 1/4. Okay, so because I have two outcomes and there's only one heads on each coin, that means I'm going to multiply 1/2 times 1/2 to get 1/4. Okay, so that was what your tree is going to look like. Now, if we look at example 3, let me erase this real quick. Example 3 says, Natalia has, 2 squares and 3 circles in a bag. Find the probability of drawing a circle, keeping it, and then drawing another circle without the use of a tree diagram. Okay, so since I'm keeping it, this is going to be a dependent event, right? Because the first one does affect the second one. So she has, let's see, two squares and 3 circles. So there are going to be 5 shapes all together. Okay, so there are 2 squares and 3 circles, 5 in all. Okay, so if I'm trying to find the probability, so the P says that what is the probability of drawing a circle the first time? So we're going to do P of the circle equals whatever, okay? Since we know that there are 3 circles and there are 5 in all, it's going to look 3/5.